Okay, so when you're finding the inverse, the first thing you want to do, step number 1 is find the determinant. And when you're finding the determinant, we cross multiply. We take A times D minus B times C. So it's 1 over that. And then over here, let's notice what happens here. The first thing that happens is these two switch. So these two do a flip-flop. So we have to flip-flop these two numbers. And then we change the sign of my B and C. Okay, so let's go ahead and practice that. And I left the formula there. Go ahead and copy down this matrix. And we're going to find, on the test, it'll say find. This is the symbol for inverse. So if it says C with a little -1, that's the symbol for inverse. So go ahead. This is just the same formula. You don't have to recopy that, but copy down this matrix, and then we will find the inverse. So the first step to find the inverse is to find the determinant of this matrix. So let's find the determinant. So the determinant of matrix C is going to equal 3 times 1. So my determinant equals 3 times 1 minus -2 times -1. All right, go ahead and type that in your calculator. And what did you get? 7? You got 1? Who got 1? Okay. So, in my formula right here, this is 1 over 1. So this equals 1 over 1 times, so we're going to flip-flop these two. So I'm going to flip-flop these two numbers right here. So the 1 moves here and the 3 moves here. And then you simply just flip the sign on these two numbers. So that becomes a +1, and this becomes a +2. So multiply. 1 divided by 1 is simply 1. So we have 1 times this matrix, which, remember, when you multiply, you just multiply all the numbers. So I'm just going to take all of these numbers and multiply it by 1. So my final answer is 1, 2, 1, 3. That is my inverse matrix. And I'll write it above here since I am in the corner. And that corner has a little thing there. So this is my final answer. Now we're going to use the inverse to solve a system. We learned how to solve a system using Kramer's. So we're going to learn how to solve a system using the inverse. So before we can do that, we need to know how to find the inverse. So let's do another example. Oops, sorry. Yes. So C -1, capital C -1 equals that. Okay, let's practice on another one. Go ahead and copy down this one here. Nope, wait, we're gonna change that one. I'm gonna change it, hold on. Because that one has a determinant of 1 also, so let me change this matrix to something that doesn't have a determinant of 1. So let's find the inverse of this one. So step number 1 is find the determinant. And what did you get for your determinant for matrix A? Who got 2? Okay, good. So now we're going to find the inverse. So the inverse is going to equal 1/2. So now we have to take 1/2. We're going to take 1/2. So put that 1/2. And now let's take our matrix and we're going to flip these two. So the 6 and the 2 switch positions. And the other diagonal, we just change to the opposite side. Now multiply those numbers by 1/2. So everything inside of that matrix gets multiplied by 1/2. So my final answer, so we have half of 2, which is 1. Half of -2 is -1. Half of -5 is -5/2. You could also say -2.5. And half of 6 is 3. And this is my final answer. That is my inverse. That is the inverse of matrix A. So now let's practice solving a system using inverses. So this is a little bit different. Well, it's actually a lot different than the way we learned last week. So go ahead and copy down this system. And on the test, you have to know how to solve it using the inverse method and how to solve it using Kramer's, okay? So this method is using inverses. So go ahead and copy this down and then we will work through it together. So let's set up our matrix. So first we're going to set up our matrix using our coefficients. So the formula says you take your matrix for your coefficient, so 6, 2, 5, 2. If we multiply that by xy, it is going to equal our constants. So working with this matrix, I want you to find the inverse. Find the inverse of this matrix right here. So in order to find the inverse, you start off by finding your determinant. And this is the same example we just did, but we'll work through it again. So the first thing we're going to do is find our determinant, which would be 6 times 2 minus 5 times 2, which is 2. And then we're going to take that and take 1/2 we're going to reverse these two numbers and then change the sign. So my inverse is 1 negative 1 negative 5/2 3. So what this method says is if you multiply this matrix, by the inverse, then we will have our solutions for x and y. So what I'm going to do is multiply both sides by this matrix. So what I'll have is matrix xy equals my inverse matrix, which is 1 negative 1 negative 5/2 3 times 13/5. So we have to go back to last week when we learned how to multiply matrices. So in order to multiply matrices, go ahead and take out your calculators if you don't have one out yet. So we're going to take this top row and multiply it by this column. So we have 1 times 13 plus negative 5/2 times 5. And then for our y, we're going to take this bottom row and multiply it by this column. So that would be negative 1 times 13 plus 3 times 5. So go ahead, take out your calculators and see what you get when you type those in your calculator. So figure out whatever you get for this red row, this is x. That's your answer for x. And whatever you get for this bottom row, which is blue, that's y. So we have 1/2. And now what did you get for your second number? 2. So that means that the solution to this system using the inverse method, let me go ahead and take away some of this. We figured out using the inverse method that the solution is 1/2, x is 1/2, and y is 2. That is the solution to this system. So let's do one more example and we'll practice using the inverse method. Go ahead and copy this one down. So you're going to flip the 3 and the 1, so that becomes this. And then we flip the sign. And when I multiply this matrix by 1 over 1, we get the same thing. So the inverse is 1, 2, 1, 3. So now what we need to do is take this matrix and multiply it by 4, 5. So matrix XY equals our inverse matrix multiplied by 4, 5. And when we multiply that, we take this top row and multiply it by 4, 5. So we have 1 times 4 plus 1 times 5. And then we repeat with the bottom row, multiplying that by 4, 5. So that would be 2 times 4 plus 3 times 5. And when you type that in your calculator, you should get that x equals 9 and y equals 23. So the solution to this system is 9, 23.